Exams of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because you will find many of the AP EAPCET papers over there, and you must download our app. The link is available in the description box for a better preparation of your exams. Student, today we'll be solving the AP EAPCET 15 May 2023 paper. I'll be solving the physics part in this particular video. We have already uploaded the mathematical part of the video of this particular paper in another video. Do explore that as well. A very best of luck. Here we go with the shift 1 paper of this date. Physics part. Very best of luck. Question number 81. Among the following, the least unit for length is parsec, nanometer, Fermi, or angstrom. See, 1 parsec is 3 into 10 raised to power 6 meters. This is 1 nanometer is 1 into 10 raised to power minus 9 meters. Fermi is this, and angstrom is this much. So what is the smallest, least unit for the length? According to this, the Fermi is the least unit because it is 10 raised to power minus 15. This is the least units. That make option C as the right answer. Next is question number 82. The time of flight of a vertically projected stone is 8 seconds. The position of the stone after 6 seconds from the ground with the acceleration due to gravity, you have to take as 10 meters per second square. Okay. See, this the stone takes a total 8 seconds to complete. Stone takes total 8 seconds to complete the flight of motion. So it will take 4 seconds for upward motion and 4 seconds for downward motion. Let the initial velocity be u. Let initial velocity be u and final velocity. See, because it is coming to the ground, so the final velocity is equal to 0. Right? So at maximum height, it is 0 at the maximum height, because at that time final velocity is 0. At maximum height, this velocity is equal to 0. And now the acceleration over there, the acceleration is given by minus g, because this is opposite in direction of u. In direction of u. So you know the formula, you have u, v is equal to u plus at, and u is equal to at, where because v is equal to 0 and minus at. Or this is equal to, because a was equal to minus g, so minus g into t. G you have been told to take as 10 and time is 4, so initial velocity is equal to 10 meters per second. Right? So when the maximum height is reached, so h is equal to ut plus half at square, you know the formula. And so you have h is equal to u is 40, t is 4 plus half into a is minus g, so minus 10, t is 4 square. This gives me 160. This is minus 80. And here you have 80 meters. So this is the height. After 4 seconds, it will fall down. There will be a free fall. After 4 seconds, there will be a free fall, and it will fall down. So at that time, distance is ut into this half at square. So you have half into a will be taken as g, because now it is falling downwards. One thing, wait, okay. And t will be taken as 2. So 2 square. Why is that? First of all, ut, this will be 0. And sorry, this is plus. Okay, ut plus half at square. So initial, when it is started to fall freely, here the initial velocity was equal to 0. So this becomes 0. Half A. Now A is equal to G, not negative of G, because it is falling freely. And why the T is equal to 2? See, the time is equal to 6 seconds over here in the question. So time of the flight vertically projected is 8 seconds. The position of the stone after 6 seconds from the ground is. So in that case, the time will be, in this case, the time is 6 seconds. So downward motion will be of 2 seconds. Right? That makes 5 into 4, or this is equal to 20 meters. Therefore, distance above the surface will be, above the surface is h minus d, so 80 minus 20, which is equal to 60 meters. So this is the answer to the question. Option B stands to be the right answer. Hope you understood this. Next is question number 83. A stone thrown with velocity u at an angle theta and 90 minus theta with the horizontal reaches the maximum height h1 and h2 respectively. Its horizontal ranges. Okay. So you are given here that the initial velocity of initial velocity of stone is u. Now first angle with which the stone is thrown, first angle of stone thrown is equal to theta, and you are given the second angle is 90 minus theta. Now the maximum height for theta is h1, and for 90 minus theta, the maximum height is h2. Height is given by, if I'm taking the angle of theta, so height for angle theta is given by h1 is equal to u square sine square theta divided by 2g. So height for angle 90 minus theta, this will be given by h2 is equal to u square sine square 90 minus theta upon 2g. That makes h2 is equal to u square cos square theta upon 2g. I hope you know this. Sine 90 minus theta is equal to cos theta, right? So now this becomes, for, let's say this is equation 1 and 2. Let's say this is equation 2 and this is equation 1. Now, from these two equations, from equation 1 and 2, let's multiply h1 and h2. You will have u square sine square theta upon 2g multiply u square cos square theta upon 2g. Right? I'll do one thing. I'll multiply the numerator and denominator by 4. So what will this be now? h1 into h2. This 2 and 2 will cancel from here. And you will have, this is equal to u square into, okay, no, I will not do the cancellations. I need this 4 over here. Wait. So upon 4 into 4. So I'll take u power 4 into 4 sine square theta cos square theta upon 16 g square. This is u. So you have u raised to power 4 into, this is equal to 2 sine theta cos theta whole square upon 16g square. Now you know 2 sine theta cos theta is equal to sine 2 theta. So that makes u square into sine 2 theta whole square upon 16 g square. Now you know one thing, that range r is equal to u square sine 2 theta upon g. So this becomes equal to, this was h1 into h2. This becomes equal to r square upon 16. Now because the range is given us, because range is given as. From here, you have r square is equal to 16 into h1 into h2, or r is equal to root of 16 multiply h1 h2. This is equal to 4 root of h1 and h2. That is equal to range. So now let's check with the options. The horizontal range is option A. Hope you understood this. Next is question number 84. Two vectors of same magnitude act at a point. Twice the product of the magnitude of the two vectors is equal to square of the magnitude of their resultant. The angle between the two vectors is. Okay, first of all, let the magnitude of the vectors be V. Let magnitude of vectors is equal to B. Angle between the vectors is, let's say that's theta. So magnitude of resultant of vectors r is given by root of v square plus v square plus 2v cos theta. Right, squaring both sides, you will have r square is equal to this, right? Or here you have that twice the product of the magnitude of the two vectors is equal to square of the magnitude of their resultant. So from here you have r square is equal to 2v square. Let's fill in this. R square is equal to 2v square. Sorry, here was square. So this makes 2v square plus this, or you have 0 is equal to 2v square cos theta. That means, of course, the v is not equal to 0. That means theta, this is cos pi by 2. So theta is equal to pi by 2. So that means the angle between the two vectors is 90 degree or pi by 2. Option C is the right answer. Hope you got that. Let's move to the next question. A car of mass 1500 kg is moving with this velocity 20 meters per second. If the brakes are applied to it and it comes to rest in 5 seconds, then what is the retarding force? So here you are given that the mass of car 1500, you are given initial velocity is this, time to stop 5 seconds. So using the equation of motion, you have v is equal to u plus at. Here, final velocity is 0, initial is this, and the time is 5 seconds. So that means the retardation acceleration is given by, from here, this is, I'll be solving, 0 is equal to 20 plus a into 5, or you have minus 20 is equal to 5a, or the retardation acceleration is 4 meter per second square, minus 4 meter per second square. Minus, it actually shows that the force is being applied opposite into the direction, to the direction of the motion. Retarding force will be, this is acceleration. So retardation force or retarding force is equal to, is given by F retardation, that is mass into acceleration. So mass was this, and this is 4. I'm taking the modulus of it. Negative sign was just showing that the force is applied opposite to the direction of motion. So this is equal to 6000 Newton. This is the retarding force. That makes option B to be the right answer. Hope you understood this. Next is question number 86. A body is made to move. Question number 86. A body is made to move up along an inclined plane of inclination 30 degree. Coefficient of friction is 0.5. What is retardation? Where G is taken as acceleration due to gravity in all these options. We have to find out the retardation. See, this is the plane, and it There is an inclination of 30 degree for this mass M, the block which is having the mass M. Let the mass of the block be M. You are having angle of inclination. You're given that this is equal to 30 degree and the coefficient of friction is 0.5. It is acting in this direction and you are having two forces in the downward direction, that is mg cos theta, and in the vertical direction, this direction, you are having mg sin theta. Right. So these are the two directions in which they are acting, and this is mg cos theta and this is mg sin theta. You have to find out net force acting on the block. This net force will be given by F net is equal to F, that is gravitational force plus the frictional force. This is your frictional force and the gravitational force. So the net force, which is given by mass into acceleration, is equal to mg sine theta plus mg cos theta. Here I'm taking the m common, so this will be g sine 30 degree, and mu will be added because this is acting in the downward direction. So mu into g into cos 30 degree. So this is m into a, and m will cancel. A is equal to, I'm taking the g again common, sine 30 is 1/2, and g, okay, g I have taken already outside. Mu is 0.5 and this is √3/2. This is equal to 1/2 plus √3/4, or this is equal to g into 2 plus √3. That makes, this is your acceleration, retardation actually. So you have option A as the right answer. Hope you understood this. Next is question number 87. A machine gun fires 300 bullets per minute, each with a velocity of 500 meter per second. If the mass of each bullet is 4 gram, then you have to find out the power of the machine gun. So here you have mass of bullet as 4 gram and the velocity is 500 meters per second. Now the number of bullet fired are 300 per minute. So the kinetic energy of all the bullets combined is given by, because there are n bullets, let's say n, this is 300 into half mv square, which is the kinetic energy of one bullet. And here you have this as 3 into half mass of one bullet is 4 grams. So I'm converting into kg, and V is 300. No, sorry, V is 500. So this is equal to 500 square. That makes this is equal to 2, and this will cancel, and you have a 0.6 into 25 into 10 raised to power 4, or you will have this as 150 into 10 raised to power 3 joules. This is the kinetic energy of all the bullets combined. Now you have to find out the power of the machine gun. Power of machine gun is kinetic energy, total kinetic energy upon time. So total was equal to this, and the time was equal to, see, it is fired per minute. And how many seconds? You have 60 seconds in a minute. So this is divided by 60. That makes, on solving, it will give you 2.5 kilowatt. Kilowatt option D is the right answer. Hope you understood this. Next is question number 88. A body falls freely from a height of 100 meters onto the ground and rebounds to a maximum height of 36 meters after collision. The coefficient of restitution between the ground and the body is Okay, fine. So initial height is 100. Initial height h1 is 100. Acceleration due to gravity 100 meter per second square. Maximum height after first rebound, this is 36 meters. When a body falls freely as given in the question, the velocity is velocity when body falls freely is given yv is equal to root 2gh for v1. Let's say v1 for h1 100 meters. So v1 is equal to 2 into g is 10. This is 100. So you have 20 root 5 meters per second. And v2 for h2, which is 36 meters. So v2 is equal to 2 into 10 into 36, which will give you 12 root 5 meters per second. Now the coefficient of restitution is given by V2 minus U2 upon V1 minus U1, where U1 and U2 are the velocity of the ground before and after the collision. Let's write down. So U1 is velocity of the ground before collision, and this is after collision. Okay, now ground is at rest. You know that. That means both are zero. Cos ground is at rest. So you becomes that E is equal to V2 upon V1, or let's fill in the values. You have 12 root 5 divided by 20 root 5. That makes E as 0.6. So you have option C as the correct answer. Hope you understood this. Let's move to the next question. Question number 89. A force of 2 iota plus 3j. This force vector in Newton acts on a particle whose position vector with respect to the origin of the coordinate system is given by this meters. If the angular momentum of the body is constant, what is the value of B? Okay. So you're given that the force is given by this vector. Let's write it down. And position vector R is given by 6I P J 12 K meters. See, when the angular momentum is constant, that means the external torque is equal to 0. Angular momentum is constant. That means external torque is equal to 0. So this is the torque is given by R cross F. So you have this vector as 6I Bj 12K cross with 2I 3J and 4K. Right? So this is 0. Let's write it down. I, J, K. 6, B, 12, 2, 3, and 4. This is equal to 0. So I into 4B minus 36 minus J into 24 minus 24 plus K. You have 18 minus 2B. This is equal to 0. That makes 4B is equal to 36 from here. because this 4b minus 36 is equal to 0. And from here you have 18 is equal to 2b. So from here you have b as 9, and from also here you have b is equal to 9. Yes, yes, I got the b as 9. So let's check. You have option B as the right answer. Hope you understood this. Let's move to the next question. Question number 90, the range of the projectile of the weight W is R. The average torque on the projectile between the initial and the final positions P and Q between the point of projection is. So this is the projectile from P to Q shown in the figure. Fine. So W is the weight of the body. Weight of body is equal to W, and the range of projectile is R. See over here, so we are having this as range. This is the angle theta, let's say. So torque is given by delta L upon delta T, where delta L is the angular momentum change in angular momentum, change in angular momentum, and you have okay, this is with respect to time. So torque is given by this. Let the initial velocity be equal to 0, and you have angle of projection as, let's say, that's theta. We just assumed that. So delta L will be given by L final minus L initial. See, L is equal to RP, or this is equal to R into M into B. So you have this as R into M into U into sine theta. Here, Li is equal to 0 as it starts from the rest, because it starts from the rest. So you have delta L as R into M into U sine theta. Also, delta T is given by 2U sine theta upon G. This is the time of projectile. Right? Let's say this is equation 1 and this is equation 2. Now put delta L and delta T in the torque equation, in this equation. In torque equation. So this is given by torque is equal to R into M into U into sine theta into G divided by delta T. This is 2U sine theta, right? So these two things will cancel, this will cancel, and you will have the torque as R into M into G upon 2. That's your torque. See, weight is equal to mass into acceleration due to gravity. So this can be written as R into W upon 2, that is equal to the torque. And let's check. You have option A as the right answer. Hope you got that. Next is question number 91. Two springs A and B fixed at the top are stretched by 8 and 16 centimeter respectively. When loads of 20 Newton and 10 Newton are suspended at the lower ends, the ratio of the spring constants of the springs A and B are. Okay. So you are given that the force or load on spring A is 20 Newtons, and how much stretch in spring A? 8 centimeter. Now force or load on the second spring, 10 Newton, and the stretch in B, 16 centimeter. Now spring force is given by minus K into X, where K is the spring constant. Spring constant and x is your displacement or your stretch. So for the spring A, FA is given by minus KA into XA, and for the second spring, force is this, right? So let's divide both of them. FA upon FB is minus minus will cancel, KA into XA upon KB into XB, or the ratio of their spring constants is equal to FA into XB upon FB into XA, which is 20 into 16 divided by 10 into 8, or this is equal to 4:1. So this is it, 4:1. We have option D as the right answer. Hope you understood this. Next is question number 92. The amplitudes of the damped harmonic oscillator between after 2 and 4 seconds are A1 and A2 respectively. If the initial amplitude of the oscillator is A0, then which of the following is true? You are having initial amplitude as A0. So amplitude at 2 seconds, A1, and amplitude at 4 seconds, A2. Amplitude of the damped harmonic oscillator, amplitude of damped harmonic oscillator is given by A is equal to A naught into E power minus alpha into D, where A naught is your initial amplitude and A is your amplitude at any time t. So the time at time t is equal to 2 seconds, A1 is equal to A naught into E power minus 2 alpha, right? So A1 upon A naught is given by e raised to power minus 2 alpha. Now at time 4 seconds, you have A2 is equal to A naught into this. So A2 is equal to, I will write this as e raised to power minus 2 alpha into e raised to power minus 2 alpha, or this is equal to A naught, A2 upon A naught. This can be written as, I'm opening this now. This was equal to A1 upon A naught into A1 upon A naught. Or you have A2 upon A naught is equal to A1 square upon A naught square. Or you have A1 square as A2 into A naught square upon A naught. So you have this as A2 into A naught, right? That gives you A1 is equal to root of A naught into A2, right? This is option A. So option A stands to be the correct answer to the question. Hope you got that. Let's move to the next question now. Question number 93, the value of acceleration due to gravity at a height of 4r e from the surface of Earth, where r is the radius of the Earth, and acceleration due to gravity on the surface of the Earth, that g is 10 meter per second square. Okay, you have to find out the acceleration due to gravity at the height 4re. Okay, so you have re as the radius of the Earth. Now height above the Earth's surface, which is given, is 4re. Height above Earth's surface is 4re. Now acceleration due to gravity at the height h above this Earth surface. Acceleration due to gravity at height h above the surface of Earth is given by G dash is equal to G naught upon 1 plus H upon R E square. Here G naught is 10 and 1 plus height is this upon R E square, or this is equal to 1 plus 1 plus 4, 10 upon 1 plus 4 square. This is G dash, or you have 10 upon 25, that gives you 0.4 meter per second square. So the acceleration due to gravity, the value of acceleration will be 0.4 meter per second square. Option C is the correct answer. Hope you understood this. Next is question number 94. The maximum possible height of a mountain on Earth is approximately. Elastic limit of the mountain rock is this, and the average density of the mountain rock is this. You have to take the acceleration due to gravity as 10 meter per second square. So first of all, let the maximum height of mountain be h. Mountain is equal to h. So here the g is nearly uniform along edge. Uniform along this edge. So maximum pressure at bottom will be maximum pressure of at bottom is given by Hg, where this is density of rock, mountain rock. Right. So now according to the question, the pressure is equal to breaking stress, and this is elastic limit. So you have this, it is equal to your elastic limit, or H is this, right? Now you have to fill in the value. You know the height of the mountain here. The average density of the mountain rock is this. Elastic limit is given to be this. Okay. So height of the mountain rock will be given by 30 into 10 power 7 divided by, you are given that average density is 3 into 10 raised to power 3. So 3 into 10 raised to power 3 into 10 Newton per meter square. Yeah. So this is equal to 3, and this will cancel at 10, 10 and 10. This will cancel. So you have 10 raised to power 4 meter, Newton per meter square minus, 4 Newton per meter square. Right? Oh, sorry, this is height. So this is meters. So height is given to you as it comes out to be 10 raised to power 4. Question number 94. The maximum possible height of a mountain on Earth is approximately how much out of these options? Here you are given that the elastic limit of the mountain rock is this, and average density of the mountain rock is this. You are given acceleration due to gravity as 10 meter per second square. Fine. So let's say first of all, h is the height of the mountain rock. Let maximum height of mountain rock is equal to h. G is nearly uniform along this edge. So maximum pressure at bottom is given by H rho G, where this rho is the density of your rock, mountain rock. Right. So according to the question, your pressure is equal to breaking stress, that is elastic limit. Right. So H rho G is equal to elastic limit, or H is elastic limit upon rho into G. Elastic limit is this, and average density is this, and G is this. Just fill in the formula. So this is equal to 30 into 10 power 7 upon 3 into 10 power 3 into this. So you have these two cancellations. So the answer is 10 raised to power 4 meters. So the maximum height of the mountain is 10 raised to power 4 meters. Okay, I have the kilometers. So 10 raised to power 4 meters is equal to 10 kilometers. That is option B is the right answer. Hope you understood this. Next is question number 95. A person of height 1.65 meters is standing upright. The additional external force required by blood vessel of length 1 centimeter, diameter 1 mm at the feet, to balance the pressure compared to similar blood vessel in the head is. Here the density of the blood is given to you as this, and G is this. Okay. Fine. You're given height of person is 1.65 meters, length of the blood vessel. So this is 1 centimeter, here this is in meters, so let's convert. This will be equal to 0.01 meters. Radius of blood vessel, this is given to you 1 mm. No, diameter 1 mm, right? So radius will be equal to 1 by 2 mm, or this is 0.5 mm. Let's convert into meters. So you have 0.5 into 10 raised to power minus 3 meters. This is the radius of the blood vessel. You have the density of blood as rho is equal to 1.1 into 10 raised to power 3 kg per meter cube. And G is 10 meter per second square. Now, the pressure difference at a depth H is P minus P naught is rho G H, where this is the pressure at atmospheric level, right? So that means delta P, change in pressure, is given by this. And P is equal to, pressure is equal to force per unit area. So you have delta F upon change in force upon the area is equal to rho GH, or change in force is rho GH into area. So the increase in force is given by delta F rho GH. What is area? This is 2 pi RH, because it is area is given by 2 pi RH. It's cylindrical in shape, the blood vessel. So because the cylindrical in shape, and the cylinder area is open from both the ends, so I will not include the two open ends like pi r square from the top and the bottom. I will not include that area. That means the change in the force, increase in the force is given by 1.1 into 10 raised to power 3 into 10, that is G, into height, that is 10 raised to power minus 2 into 2 into pi into R, which is 0.5 into 10 raised to power minus 3, and H is this again. Okay, and on solving this, you will get the delta F is equal to 0.57 Newton. That makes option A to be the right answer. Hope you got that. Next is question number 96. The specific heat capacity of a copper block of mass, here is mass M, and I'm repeating the question. The specific heat capacity of a copper block of mass M is given by small s. If the mass of the copper block is doubled, the specific heat capacity will be. See, first of all, you need to understand what is specific heat capacity. Specific heat capacity is the amount of heat required to raise 1 gram of any substance by 1 degree Celsius. It does not depend on the mass of the substance. So even if the mass of the copper block is double, the specific heat capacity will not change. It will remain the same. That makes option C to be the correct answer. Hope you got that. Next is question number 97. 2 moles of monoatomic gas require heat capacity Q to be heated from 30 to 40 degree at the constant volume. The heat energy required to raise the temperature of 4 moles of diatomic gas from 28 degree to 33 degrees Celsius at constant volume is. So here you are given that 2 moles of monatomic gas required heat energy Q to be raised from this to this. Question number 97. 2 moles of monatomic gas require heat energy Q to be heated from 30 to 40 degrees Celsius at the constant volume. The heat energy required to raise the temperature of 4 moles of diatomic gas from 28 to 33 degree at constant volume is. See, we are talking about the constant volume. So the heat capacity at constant volume for monoatomic gases is 3 by 2R, and the same for diatomic uh, gas is 5 by 2R. Number of mole of the monatomic gases are 2, and the number of diatomic gases is given to you as 4 moles. Number of moles of monoatomic gas is 2, and number of moles for diatomic gases 4. Now heat energy required by the monatomic gas, it's Q, let's write it. Heat energy required by monoatomic gas is equal to Q. Here the increase is from 30 to 40 degrees Celsius. That means the heat energy is given by, for the monoatomic, this is given by Q is equal to NCV into change in temperature. This is 2 moles. This is 3 by 2R, and change in temperature 30 to 40. We are moving 10 degrees. So this is equal to 30R. That means Q is equal to 30R. Let's say this is 1. Now the heat energy required by the diatomic heat energy required by diatomic gas, that is given by, let's say this is Q2, this is N into CV into change in temperature. This is equal to 4 moles, 5 by 2R. Now the temperature has to be risen from 28 to 30. So this is 33 minus 28, or this will be equal to, so this is 50R. This is Q2. Let's say this is equation 2 from 1 and 2. You have Q1 as 30R and Q2 as 50R. That gives you Q2 is equal to 5 by 3R, right? And I think I got the answer. This is what we needed to find out. Yes. So that makes 5 by 3Q. That's it. Option D is the right answer. Hope you understood this. Next is question number 98. A block of steel of mass 2 kg slides down a rough inclined plane of sine inverse 3 by 5 at constant speed. The temperature of the block as it slides to 80 centimeter, assuming that the mechanical energy lost is used to increase the temperature of the block, is nearly. Here you have the specific heat capacity of steel as this, and acceleration due to gravity is also given to you, that you have to take 10 meters per second. Now, mass of the block is 2. Mass of block, let's say M is equal to 2 kg, and the angle of inclination is sine inverse 3 by 5. Now, specific heat capacity is also given. Specific heat capacity of steel is 420 joules per kg per Kelvin. Acceleration is due to gravity is this. Now, heat energy absorbed is heat energy absorbed is given by delta Q is equal to M into C into change in temperature. Work done is equal to loss in kinetic energy. Work done is equal to loss in the kinetic energy, right? How much energy is lost? That is equal to the work done. So delta E is equal to work done, which is equal to mg sine theta multiplied by L. See, work is equal to force into displacement. So let's say this is equation 1 and this is equation 2. Work done is equal to a change in kinetic energy. That means from 1 and 2, you have these two as equal. So you have mc delta t is equal to m g sine theta into L, or delta t is equal to g, m and m will cancel. G into sine theta into L upon C. Right. So the increase in temperature, which is delta T, is given by that will. You have G sine theta. See, you had that theta is equal to sine inverse 3 by 5. So sine theta is 3 by 5. This is 3 by 5. L is equal to, what is L equal to? It is, it is 80 centimeters. So that means it's 0.8 meters. So L is equal to 0.8, and you have the C as 420. It's given in the question. On solving this, you will find out delta T is equal to 0.0114 degrees Celsius. That makes option B to be the correct answer. Hope you understood this. Let's move to the next question. Number 99. Isothermal bulk modulus of a gas at a pressure P is, where this is the ratio of specific heat capacities of the gas. Question number 99. Isothermal bulk modulus of a gas at a pressure P is given by which of these options? Here, the gamma represents the ratio of specific heat capacities of the gas. See, what is the formula for the ideal gas? PV is equal to nRT, and PV is constant for isothermal processes. For the isothermal process, and let's differentiate it. So you will have P delta V plus V delta P. This is equal to, see, this is constant, that means this is equal to 0. Or you have delta V upon V is equal to minus delta P upon P. Isothermal bulk modulus, thermal bulk modulus is given by B isothermal is equal to minus delta P upon delta V upon V. Let's say this is equation 1 and this is equation 2. Now put the value of delta V upon V from here to here. You will have isothermal bulk modulus is equal to minus delta P divided by delta P upon P, or this is equal to P only. So the bulk modulus is equal to P. That makes option C to be the correct answer. Hope you understood this. Next is question number 100. A vessel of volume 10 liters is filled with hydrogen gas. The total average translational kinetic energy of its molecules is given by this. The pressure of the hydrogen in the vessel is. Okay, see, the volume of the hydrogen gas is 10 liters. Average translational kinetic energy is 4.5 into 10 power 5 joules. So convert the volume into the SI units. So you will have, okay, I'll write it here only. This is equal to 0.01 meter cube. Because when it is divided by 1000, it will give you this. Okay. So the pressure of the gas when energy is given is of pressure of gas when energy is given by P is equal to 2 by 3 into E upon V. So this is E is 4.5 into 10 power 5 upon 3 into volume is 10 liters, which has been converted. So 0.01. That gives you, let's do the cancellations. Here is 1.5. So you have 3 into 10 power 7 Newton per meter square. Or 3 into 10 power 7 is not there, but I have this 30 into 10 power 6 Newton per meter square. That is option B is the correct answer. Hope you got that. Let's move to the next question, number 101. The small amplitude progressive wave in a stretched string has a speed of 10 centimeter per second and the frequency of 100 hertz. The phase difference between the 2 points this centimeter apart on the string in radians is. You have the wave speed as 100 centimeters per second. Let's convert into SI units. So 1 meter per second. Frequency is 100 hertz. Frequency 100 hertz. And then you have the path difference as 2.75 centimeters, or this is equal to, let it be like this only. Okay, if I'm converting into meters, this will be equal to like this. Yeah. 0.275 meters. Wavelength of the wave having frequency, wavelength of the wave having frequency is equal to 100 hertz is given by lambda is equal to C upon F. Here the C is 1 by 100. So this is 1 upon 100, right? F is equal to 100. So this is equal to 0.01 meters. This is your wavelength. Now phase difference between the 2 points. Difference between 2 points with path difference delta x is given by 2 pi upon lambda into delta x. This is equal to 2 pi upon lambda is 0.01 and delta x is 0.0275. Or you have this as 2 pi into 2.75, or this will be equal to 11 by 2 pi radians. That makes option B to be the correct answer. Hope you understood this. Next is question number 102. Blue color of the sky is due to reflection of light, refraction, diffraction, or scattering of light. See, when the sunlight, question number 102, blue color of the sky is due to reflection of light, refraction, diffraction, or scattering of light. See, when the sunlight reaches the Earth's atmosphere and it is scattered in all the direction by the gases, dust particles present in the atmosphere. Scattering takes according to Rayleigh scattering. Scattering at that time takes effect due to Rayleigh, according to the Rayleigh scattering, which gives the scattering is inversely proportional to fourth power of wavelength. Thus, the blue color has the small wavelength and the scattering is very large. Therefore, the blue color of the sky is seen. That gives you D option as the correct answer. Next is question number 103. The property of light which cannot be explained by Huygens' construction of wavefront is refraction, reflection, diffraction, or origin of spectra. Okay, see, Huygens' principle state that every point on wavefront on a wave will act as a fresh source for the next wavefront. Huygens' wavefront is based on wave nature of light. In reflection, refraction, and diffraction, all of these we can see superimposition and interference which can be explained by Huygens wavefront. Origin of spectra is not explained by it because it has different values of emissions. Hence, you have option D as the correct answer. Hope you got that. Next is question number 104. The electric field in region given by E, the net electric flux through the same area. Question number 104. The electric field E in Newton per coulomb in a region given by this, the net electric flux through the square area of side 2 meters, which is parallel to the YZ plane, is. So you are having the electric field given by the vector 3I plus, here it should be J, 3I plus 5J. And the side of the square, since the square is parallel to the YZ plane, so the side of the square is given by 2I because it's parallel to YZ plane. Okay, so therefore the electric flux is given by E into this unit vector for the side of the square into ds, where this is the area. This represents the area. That means the electric flux is given by, this is equal to 3I plus 5J, and this is multiplied by 2 cross 2I. So this makes it 3 into 4 plus 5 into 0. 3 into 4 plus 5 into 0, that is equal to 12 Newton meter square per coulomb. So the answer to the question, option C. Hope you got that. Next is question 105. The two thin conducting concentric shells of radii R and 2R are shown in the figure. The outer shell carries a charge of positive Q and the inner shell is neutral. Then the correct statement is, okay, number 1, when the switch is closed, the potential on the inner shell becomes 0. Number 2, when the switch is closed, the charge on the inner sphere is Q by 2, minus Q by 2. Fine. See, you are having that the radius of the inner shell is R and for the outer shell, it is 2R. Right? This is 2R and this is equal to R. Charge on the outer shell is given to you as Q. Right. Now, inner shell is neutral. Inner shell is neutral. Let Q be the charge attained by, wait, let Q be the charge which is attained by the inner shell. So by Ohm's law, question 105, two thin conducting concentric shells of radii R and 2R are shown in the figure. The outer shell carries the charge Q. And the inner shell is neutral. This inner shell is neutral, and the correct statement is when the switch is closed, the potential on the inner shell becomes 0, or when the switch is closed, the charge on the inner sphere is minus q by 2. So you are having two spheres. First is having the radius of r, and the one is having the radius of 2r. This is q. So the charge on the outer shell is given to you as positive q. Inner shell is given to you as neutral. It's given inner shell is neutral, and this is there. So these four things are given to you. Now let's start. Let q be the charge attained by inner shell. Therefore, when switch is connected, see over here, if I make the switch, this one, if switch is already given to you, when the switch is connected, the inner shell is earthed, so the potential at any point on the surface is 0. And when the switch is open, no charge flow, no charge flow, and the potential is 0. Therefore, V inner sphere is equal to 0. That is equal to K into Q upon 2R plus A into small q upon R. That means this is equal to 0. This makes, we have to find out the value of Q. So you have K into Q upon R is equal to minus K Q upon 2R. K will cancel, R will cancel. You have Q as minus Q upon 2. Okay, so that means option, when the switch is closed, wait. Okay, when the switch is closed, the potential on the inner shell becomes 0. That is absolutely correct. And when the switch is closed, the charge on the inner sphere is minus q by 2. So both are correct. That makes option A to be the correct answer. Hope you understood this. Next is question number 106. Two square-shaped metal plates of side 1 meter kept 0.01 meter apart in air from the parallel plate capacitor. It is connected to a battery of 500 volt. The plates of the capacitor are then immersed in an insulating oil while lowering the plates vertically with a speed of this much. If the dielectric constant of the oil is 11, then the current drawn from the battery during the process is which of the following? Okay, so you are given here that the side of the square plate is side of square plate is 1 meter. Distance between the plates is given to you as 0.01 meters, and voltage of the battery is voltage of the battery 500 volt. Now speed of immersing in oil, speed of immersing in oil is equal to 0.001 meter per second. Dielectric constant of oil, so many things, dielectric constant of oil is equal to 11. Now we have the combination of two parallel plate capacitor. So this is the figure here. This is the direction of the flow of the current. I is flowing in this direction. This is D, that is distance between the two plates. Let this be X. So this much will be 1 minus X into I. Now, first is the electric with, first is with dielectric is as air, and the second one is dielectric as oil. First one, let's write it down. First is with dielectric as air, and the second dielectric as oil. Net capacitance will be given by C is equal to A1 E naught upon D plus A2 E naught K upon D. Or you have C is equal to E naught into 1 into 1 minus X upon D plus 11 E naught into 1 into X upon D. So this will give you, let's take this common, or you have 1 minus X and plus 11x. So this gives you E naught upon D 1 plus 10x. This was equal to your net capacitance. Now the charge is given by Q. Charge is given by Q is equal to CV, and current, current is dc upon dt, that is I into V, or this is equal to dc into dV into I. Okay, that is equal to current. dc upon dt into V. So you have this is equal to V. I'm writing it over here, and d by dt of E naught upon D 1 plus 10x, or this is equal to 10V E naught upon D dx by dt. Now you have already dx by dt is equal to this meters per second. This is given to you, dx by dt, that is equal to V is given by this. So let's fill in over here, putting all the values in this equation. You will have the current is equal to 10 into 0 0.001 into E naught was question number 106. Two square-shaped metal plates of side 1 meter kept 0.1 meter apart in air from a form of parallel plate capacitor. It is connected to a battery of 500 volts. The plates of the capacitor are then immersed in an insulating oil by lowering the plates vertically with a speed of this much. The dielectric constant of the oil is 11, and the current drawn from the battery during this process is how much? Okay, so you have a number of things. First of all, you have a side of square plate is 1 meter, and the distance between the plates is 0.01 meters. Voltage of the battery 500 volts, and the speed of immersing in oil 0.001 meter per second. Dielectric constant of oil is equal to 11, and in this question I'll be taking E naught as 8.85 into 10 raised to power minus 12 coulomb square per Newton per meter square. So we have a combination of here we have a combination of two parallel plate capacitors. Therefore, this is something like this. These are the two parallel plates, and here you have the battery. The current is flowing in this direction. This is a 500 volt battery. This is the direction of flow of current. This is your D, and this is your oil. Right. If this is X, this is equal to 1 minus X. Right. So, okay, let's get back to the question. Now, first is with dielectric as air, and the second is with dielectric as oil. So the net capacitance will be given by C net, will be given by A1 E naught upon D plus A2 E naught K upon D. Or this is equal to E naught into 1 minus X upon D plus 11 E naught into 1 into X upon D. I'm taking this common. So here you have 1 minus X plus 11X. This is equal to E naught upon D 1 plus 10X. This is equal to the total capacitance. Now the charge is given by charge Q is equal to CV, and the current is given by dC upon dt is equal to I into V, or you have I is equal to V into dC upon dt. From here, I will take the current. So what is C equal to? That means I is equal to V into d by dt of E naught upon d 1 plus 10x, or this is equal to V into 10 into E naught upon d dx by dt. Now in the question you are given dx by dt is equal to 0.001 meters per second. So let's fill all the values. You have this as 510. E naught is 8.85 into 10 raised to power minus 12. Distance d is given to you as 0.01 meters, and this is 0.001. So solving all of them, you will get the value of I as 4.425 into 10 power minus 9 ampere. That makes option C to be the correct answer. Hope you understood this. Next is question number. Question 7. When a resistance R1 is connected across a cell, the current I1, and if the resistance R1 is replaced by R2, the current is I2. Then the internal resistance of the cell is. So you are having, when R1 is connected to the battery, I1 is the current, and when R2 is connected to the battery, the current flowing is I2. So this is something like this. Okay, so this is the battery. Let's say this is the charge E, this is the direction of the current flowing, this is I1, this is R1 resistance, and this is internal resistance of the cell. And here you have the second battery, second circuit. Again, you have this as R. Now the resistance is replaced by R2, and this is the one. So now the current flowing is I2. Okay, now you are asked that what is the internal resistance of the cell. So I'll be using the Ohm's law. Ohm's law says that current is equal to V upon R, and this is equal to, here the total resistance is R plus R because they are connected in the series. So this is your internal resistance. So you have I1 as E upon R plus R1 and I2 as E upon R plus R2. Saying see, E is same in both the cases. So I1 into R plus R1 is equal, this is one thing. So I2 into R plus R2 is equal to E. So that makes both of them to be equal. That means you have I1 R plus R1 is equal to I2 R plus R2, or you have I1 R plus I1 R1 is equal to I2 R plus I2 R2, or I1 R minus I2 R is equal to I2 R2 minus this R common. I1 I2 is equal to this. So the internal resistance is I2 R2 minus I1 R1 upon this. So this is the answer to the question. Let's check with the options, which is the right one. Option D is the correct answer. Hope you understood this. Next is question number 108. Charge passing through a conductor of cross section 0.3 meter square is given by Q is equal to this much coulomb, where T is time in seconds. The drift velocity T is equal to 2 seconds is concentration of the electrons in the conductor is should be taken as this much. All right. So here you have the area of cross section of conductor as this much, and the charge is given to you 3t square 5t plus 2c time 2 seconds. Concentration of electrons in the conductor is 2 into 10 power 25 per meter cube. Current is the rate of change of charge, rate of change of charge. That means I is equal to dq upon dt. That is equal to d small q upon dt. Or this gives you I is equal to d by dt. Now q is 3t square plus 5t plus 2. So I is equal to 6t plus 5 ampere. At 2 seconds of time, at the time t is equal to 2 seconds, current will be given by 6 into 2 plus 5 ampere, that is equal to 17 ampere. Now the drift velocity is given by the formula. Drift velocity is I is equal to NAVQ. Here, I is your current and N is the number of electrons. Let's fill in that. We have to find out this V. First of all, V will be equal to I upon NAQ. I, we just calculated, that is equal to 7. N is 2 into 10 power 25. A is 0.3 area, and Q is charge on an electron is 1.6 into 10 raised to power minus 19. On solving this, you will have the value of V as 1.77 into 10 raised to power minus 5 meters per second. So that is it. Option C is the right answer. Hope you got that. Next is question 109. The magnetic field intensity at the center of the circular wire of radius 0.1 meters carrying a current of 0.2 ampere is. So here you have radius of wire as 0.1 meters and the current in the wire 0.2 ampere. Magnetic field intensity, magnetic field intensity at the center of current carrying loop is given by B is equal to this. Okay, so let's fill in. You have mu naught and this is 0.2. This is divided by 2 into 0.1. So that's it. You have B is equal to mu naught. So this is equal to 4 pi into 10 raised to power minus 7t. That makes option D to be the right answer. Hope you got that. Let's move to the next question. Question 110. A wire is first bent in the form of a circular coil of 5 turns, and the same wire is then bent in another circular coil of 10 turns. If the same current is passed in both the coils and the ratio of the magnetic fields at their centers is. So first case, you have the number of turns as 5 and let's say length of wire as L. And in the second case, number of turns is equal to 10. And of course, the length will be the same. Length of the wire will be L only. Now, radius of the loop for both cases will be radius of loop for the first case, N into 2 pi R1 is equal to L because that is the length of the wire. Course. So from here you have R1 is equal to L upon 2 pi into N1. This is equal to 2 pi N1 is 5 or this is equal to L upon 10 pi. Let's say this is equation 1. Now for N2, this is for the first case and this is for the second case. You have N into N okay, in the second case, this was N1, right? Okay, so here you have N2 into 2 pi R2 is equal to L. That gives you R2 is equal to L upon 2 pi into N2 or L upon, this is L upon 2 pi and 10 or this is equal to L upon 20 pi. This is equation 2. Now the magnetic field due to current carrying coil, magnetic field due to current carrying loop is given by B is equal to mu naught N I upon 2R. For B1, let's say wait. So for loop with the radius R1, B1 is equal to 5 mu naught I upon 2 multiplied by 2 pi upon L. And for the loop with R2 radius, you have B2 as 10 mu naught I upon 2 into 10 2 pi upon L. So say this is equation 3 and this is equation 4. So dividing 3 and 4, you will have dividing 3 and 4, you will have B1 upon B2 is equal to 5 mu naught I. Okay, I'll do the cancellations. Okay, no, nothing. 5 mu naught into 5 into 2 pi divided by 2 into L multiplied to L, 10 mu naught L, 10 2 pi. So 2L, this thing, some things will cancel. Here was I. So this and this, and the 5 to this and this, and 2 pi and 2 pi. So lots of cancellations will be there. Ultimately, you will be left with this is equal to 1 by 4. Okay, since see, current is same for both the loops. I is same. That is why I have cut them. Same for loops. So that means the ratio is 1 by 4. That makes option D to be the right answer. Hope you got that. Next is question number 111. A solenoid has a core of material with a relative permeability as 400. The windings of the solenoid are insulated from the core and carrying a current of 4 ampere. If the number of turns is 500 per meter, then the magnetizing field is. Okay, see, here you have the relative permeability. Permeability as 400 and current is 4 amperes. Number of turns per meter is given to you as 500. So the magnetizing field magnetizing field H is equal to N into I. So this is equal to 2000. Right? See, why is that? Because you have B is equal to mu H and H is equal to B upon mu, and this is equal to mu naught I upon mu. Okay. So you have H as 2000, which is equal to 2 into 10 power 3 ampere per meter. That makes option D to be the right answer. Hope you understood this. Let's move to the next question number 112. In an AC generator, if the coil of N turns and area A is rotated at V revolutions per second in a uniform magnetic field B, then the motional EMF produced is equal to at T is equal to 0 second, the coil is perpendicular to the field. Do remember this at the time is equal T is equal to 0 seconds, the coil is perpendicular to the field. Let's read this the whole sentence or the question once again. In an AC generator, the coil of N turns and A area is rotated at V revolutions per second in a uniform magnetic field B, then motional EMF produced is equal to which of these options? Okay, so here you are having number of turns in coil is equal to N, or you have area of coil as A, magnetic field as B. It's given over here, revolution per second is equal to V. So EMF produced is given by Faraday's law of electromagnetic induction. That is E is equal to N into d phi upon dt. That is rate of change of flux induces EMF. So the flux is given by B into A, that is the dot product of B and A, that is BA cos theta, that is equal to B into A cos omega t. You know theta is equal to omega t. Let's say this is equation 1 and this is equation 2. So let's put the value of flux in equation 1. So put 2 in equation 1. You have mod of E as N into d by dt of B A cos omega t, or this is equal to N B A cos omega t. This will be sine omega t. Let's say this is equation 3. So this will become E is equal to NBA 2 pi V sine 2 pi V. Here is something, wait, I forgot to write omega over here, because the derivative of omega t will give you omega. Okay, so this is the right answer to the question, and let's check. You have option A as the correct answer. Hope you understood that. Next is question number 113, the frequency of AC at which 16 micro F capacitor and 10 upon pi square mH inductor will have the same reactance is. Question number 113, the frequency of AC at which a 16 microfarad capacitor and 10 by pi square mH inductor will have the same reactance is. So here you have the capacitance C as 16 microfarad and the inductance L is equal to 10 upon pi square micro H. And C, the capacitive reactance is given by Xc is equal to 1 upon omega C, where this is your angular frequency. So inductive reactance will be given by XL is equal to omega L, or this is equal, sorry, or XL is equal to omega L, or you have XC is equal to, wait, or you have XC is equal to XL. That means 1 upon omega C is equal to omega L, or cross multiplication, you have omega square is equal to 1 upon LC, or omega is equal to 1 upon root of LC. Here F is your frequency. If I'm taking F as your frequency, so this omega is equal to 2 pi F. This is equal to 1 upon root of LC, or your frequency is equal to 1 upon 2 pi root of LC. Now let's put this thing in the given equation. Wait. Okay, no, sorry, let's continue with this equation only. So you have F is equal to 1 upon 2 pi upon L is 16 into 10 raised to power minus 6, and this is 10 pi square into 10 raised to power minus 3. You are given the value of L and C. I'm just filled in those values. So on solving, you will have F is equal to 1.25 into 10 raised to power 3 hertz, or this is simply 1.25 kilohertz. That makes option B to be the right answer. Hope you got that. Next is question number 114. The average power output of a point source of an electromagnetic radiation is 1080 watt, and the maximum value of the RMS value of the electric field at a distance of 3 meters from the source is. So here you have that average power of EM radiation by point source, that is the P average is 1080 watt. Distance is distance R is 4 meter. So let the electric flux be donated by E naught, electric field be denoted by E naught, electric field. So intensity of electromagnetic wave is given by I is equal to P average divided by area. Or this is equal to this, right? So you have P AV upon A is equal to this. See here, A is area is equal to 4 pi r square. C is the speed of light, and this is the permeability. So E naught will be equal to 2p AV into mu naught C upon 4 pi r square part 1 by 2. Now fill all the values. You have 1080 into 4 pi into this into this whole divided by 4 pi into 16. So the RMS value of the electric field E naught is equal to 60 volt per meter. Okay, so C is the right option. Hope you understood that. Next is question number 115. The velocity of the particle A is 3 times the velocity of the proton. If the ratio of the de Broglie's wavelength of the particle A and the proton is 3:2, then the mass of particle A is what? Here MP represents the mass of the proton. Okay, so you are having velocity of the particle A is equal to 3 times velocity of the particle B. Okay, now de Broglie's wavelength ratio Broglie's wavelength ratio of particle A and B, they are given by lambda A upon lambda B is equal to 3 by 2. You are having that particle B is a proton. So therefore, de Broglie's wavelength is given by lambda is equal to h upon p. That gives you lambda is equal to h upon mv, or you have m is equal to h upon lambda into v. Now, what is the mass of particle A? Mass of particle A is this, right? So for the B's mass of particle B is given by this. So let's say this is equation 2 and equation 1 dividing 1 and 2. Dividing 1 and 2, you have MA upon MB is equal to this. This gives you MA is equal to MP 1 by 3 into this. So you have that MB is your proton mass of, here I've taken MB as the mass of proton. So VA upon VB is equal to 3. Question number 115, the velocity of the particle A is 3 times the velocity of the proton. If the ratio of the Broglie's wavelength of particle A and the proton is 3:2, you have to find out the mass of A. So you are given, first of all, that the velocity of A is 3 times the velocity of B, where B I'm representing as your proton. That gives you VA upon VB is equal to 3 upon 1. Let's say this is number 1. And according to the de Broglie's wavelength, the ratio of wavelength of particle A and B is equal to 3 by 2. Let's say this is number 2. Okay. So now Broglie's wavelength is given by Broglie's, de Broglie's wavelength is given by, according to him, wavelength is given by h upon p, which is equal to h upon mv. So m is equal to h upon lambda into v. Now, for particle A, what will be it? Mass ma will be given by h upon lambda a into va. And for particle B, which is your proton, mb is equal to h upon lambda b into vb. Now, let's divide both of them. What you will get, dividing both of them, you will have ma upon mb is equal to lambda b into vp upon lambda a into va. And let's put in the value from here. So va upon vb, this is, first of all, lambda b upon lambda a, this is equal to 2 by 3. And this is equal to 1 by 3. So you have ma is equal to mb into 2 by 9. This is the answer to the question. See, in the question, you have to take the mass of the proton as mp, but I have taken in the question mb. So that is simply, they are one and the same things. Okay. So that makes your first option to be the correct answer. Option A is the correct answer. Hope you got that. Next is question number 116. The transition of an electron in an hydrogen atom that emits a photon whose wavelength lies in the ultraviolet region of the electromagnetic spectrum is. See, the wavelength of the ultraviolet waves, wavelength for ultraviolet waves lie in the region of 100 to 400 nanometer. The wavelength of transition is given by Bohr's equation. So this is given by 1 upon lambda is equal to R into 1 upon NF square minus NI square. Here, NF is the state where electron goes to transit. So also, you know that lambda lies in the range of 100 to 400 nanometer if the transition is in Lehman series. So wavelength lies in the range of 100 to 400 nanometer if the transition lies in Lehman. Transition is in Lehman series. So that makes 1 upon lambda is equal to R into this. So here the transition start from n is equal to 2. So the transition from will be from n is equal to 2 and n is equal to 1. That makes D option to be the correct one. Hope you got that. Next is question number 117. It says the relation between the mean lifetime and the half lifetime of the radioactive element is. Okay. So let's write down first. The half lifetime of the substance is given by half lifetime of a substance is given by T1 by 2 is equal to log 2 to the base E upon lambda. This is your TK constant. Also, the mean life. This is inversely proportional to, or this is 1 upon lambda. From here, you have lambda is equal to this. So let's put in this value in this equation. You will have 2 to the base E upon 1 upon this. So you have log 2. This is the answer to the question. That makes option A to be the correct answer. Hope you understood this. Next is question number 118. A PN junction diode is reverse biased with the voltage of 8 volt. If the resistance of the diode is 4 into 10 power 7 ohm, then the reverse saturation current is. See, the PN junction voltage here is 8 volt. and resistance of diode is this much, 10 power 7, 4 into 10 power 7 ohm. So using Ohm's law, you have V is equal to IR. So I saturation, that is a saturation current, is given by this, or you have this is equal to 10 into 2 into 10 power minus 7 ampere, or I have the answer in the microamperes. This will be equal to 0.2 microamperes. That makes option C to be the correct answer. Hope you understood this. Next is question number 119. In a PNP transistor, emitter is heavily doped and collector is moderately doped. Emitter is moderately doped and the collector is heavily doped. Both emitter and collector are heavily doped. Both emitter and collector are moderately doped. See over here. I'll make a PNP transistor. So this is the one, PNP, like this. This is your emitter, base, and transistor. Oh, sorry, this is collector. This is your PNP transistor. Okay. See, in a transistor, emitter is heavily doped because it has to inject a very large number of charge carrier into the base. Okay. The base is lightly doped and very thin. It passes most of the emitter injected charges. Collector is wider than other two regions and moderately. Yeah. A collector is wider than the other two regions and moderately doped. This is done to collect majority of the charge carriers from the emitter. I'm repeating this whole thing. The transistor emitter, this is heavily doped, and because it has to eject a very large number of charge carriers into the base, and the base is lightly doped and thin. Very thin actually, and it passes most of the emitter, which is from the Question number 119. In a PNP transistor, emitter is heavily doped and collector is moderately doped. Emitter is moderately doped, collector heavily doped. Both are heavily doped, or both emitter and collector are moderately doped. See, let's make the PNP transistor first. So here is your PNP. So this is your emitter and collector and base. This is your PNP transistor. See, in a transistor, the emitter is heavily doped because it has to inject a large number of charge carrier into the base. And the base is lightly doped and very thin. It passes most of the emitter injected charges. Collector. It is wider than the other two regions and moderately doped. This is done to collect majority of the charge carriers from the emitter. That makes first option to be the correct answer. Hope you understood. Next is question number 120. This is the last question for your physics section. So it says the peak voltage of carrier, the peak wave of question number 120. This is the last question of your physics section. It says a carrier wave of peak voltage 15 volt is used to transmit a message signal. If the modulation index is 60%, then the peak voltage of the modulating signal is. Okay, so here you are given that the peak voltage is 15 volt. Peak voltage of the carrier wave is 15 volt. And the modulation index 60%. Modulation index is the ratio of maximum amplitude of the signal wave to the carrier wave. So this Modulation index, this is the ratio of the maximum amplitude of the signal wave to the carrier wave, where this represents your peak voltage of modulation signal. And so you have this as 60%. So this is 60 upon 100. This is AM. AC is given to you as 15. That gives you AM is equal to this, or this is equal to 9 volt. And the peak voltage of the modulating signal is 9 volt. Option C is the correct answer to the question. Hope you understood that. Let's move to the next question, number 121. Students, now we are going to start with the chemistry section.